Hey guys, so today we're going to be working in 7.2 and 7.3. I'll try to make sure this video kind of goes through those two examples really clearly, and then I'll post that video to both sections. We're going to continue this concept of solving a linear system, which, you know, what we worked on last time was this idea of graphing two lines and finding that location where they cross. Now that works so well when we have a graphing calculator and the numbers are whole numbers, but the truth is the world is not full of perfect numbers. And so when we start to deal with real world problems, oftentimes we have to have other approaches besides just graphing. And so that's what we're going to focus on here. In 7.2, we're working on number 3 through 11. And if we take an example like question number 5, okay? The first thing we want to do is find a variable that is either already alone or really easy to get alone. And if you look at the top equation on number 5, do you see how x is on the left side completely alone? That is our substitution that we want to use. It says that x is the same thing as a y plus a 3. So that means mathematically there is no difference between using x and using y plus 3. So in my other equation, okay, where it says 2x minus y equals 5, I could, instead of using x, I could use y plus 3. And this equation would read 2 times not x, but something that is exactly the same value, y plus 3 minus y equals 5. Notice with me that the x has been replaced, but nothing else in the problem changed in that second equation. Now I do have to do a little bit of cleanup. For instance, I'm going to have to distribute this 2 and multiply it by each of these to produce 2y plus 6, still minus y equals 5. I want to combine any like terms I have, and since I have a 2y and a negative y, well, 2y minus y is a regular y. I still have plus 6 equals 5, and to finish it, I will minus 6 from both sides, and y now equals negative 1. What this tells me is that wherever these two lines are crossing, the y value is negative 1. I still don't know where it is left and right, but I do know that it's at a value of negative 1. If I use that negative 1 back in the original substitution equation, my x is said to be equal to y, which I know is negative 1 plus 3. Well, x is negative 1 plus 3 would equal 2. So that means that at the point 2 for x, negative 1 for y, these two lines on number 5 will cross at exactly that location. This is what we're finding. Now sometimes on these you're going to find that the x or the y isn't already alone. Here on number 8 you can see I already have y equals. Great. But what happens when I come down here and I look at questions like number 10? Is the x alone? Is the y alone? No, there's stuff on that left side. There's too many things going on. On the bottom equation, x isn't alone, but it's sure close. In fact, if I just add 9, then that would give me x equals 8. And now x is alone, and I can use 8 instead of my x in the other equation. Hopefully this reminds you or walks you through those steps. Remember, the example problems at the top of the textbook can also help you with that. So right now we're going to clear this off, and we're going to go look at 7.3, where we take a little bit of a different approach, because there's always more than one way to solve a problem. And that's what we're going to focus on here in 7.3. Let me get that cleared off. There we go. We'll jump over to 7.3 where the assignment's just slightly different. Here, we get to certain problems, and on number 3, I could get x alone, or I could get y alone. It's not that hard, but sometimes we end up with really cool situations. Let's take number 5 here. I gotta grab my pencil. Grab number 5 here. We have a negative 3x minus y equals 8, and we have 7x plus y equals negative 12. Now, a little coincidence, okay, something that we don't always realize. If you take 2 plus 4 equals 6, and 3 minus 1 equals 2, if you added the right side, you'd get 8. If you take 2 plus 3, you get 5. 4 plus a negative 1 is 3, and 5 plus 3 equals 8. Turns out we can add the left side of an equation to the left side of another equation as long as we also add the right sides. And we end up with a still valid equation. Do you see right here how we have a negative y and then a positive y? Those will cancel when I try to add these two equations together. That will leave me with a negative 3x plus 7x, or 4x. I bring down my equal sign, and 8 plus negative 12 is negative 4. By dividing by 4, my x will be isolated, and x equals negative 1. So I didn't have to do substitution. I just added the equation and divided by the coefficient. The one downside to using this method is I don't really have a quick way to find y. I'm going to have to grab one of these equations. Let's take the bottom equation. And I'm going to have to use it to be able to figure out what y is. So 7 times x is negative 1, we just learned that, plus y equals negative 12. Well, 7 times negative 1 is negative 7, plus y equals negative 12. And to finish it, I just get rid of the 7, and I will get y equals negative 5. Meaning that at the point negative 1 for x, negative 5 for y, these two lines will cross at that exact location. Later in the assignment, we're doing 3 through 14. In the second half of this assignment, you'll notice that the numbers the way they are don't actually cancel. Let's take a look at number 9 here. Okay, if we look at number 9, an x and a negative 2x don't cancel. And a y don't cancel. One of them has to be positive, one of them has to be negative. So the way we're going to fix that is by leaving one of the equations just the way it is, x plus y equals 1. The other equation we're going to times by a negative 1. And all that's going to do is change every sign in the problem. So this second equation is now going to be a positive 2x, a negative y equals a negative 4. That's going to give me 3x. The y's cancel, and this equals negative 3. Dividing by 3, x equals negative 1. I promise x is not always negative 1. But to find my y, I do have to plug back in. So let's take this top equation. X plus y equals 1. If x is negative 1, plus y equals 1, right? We got x was negative 1. I'd have to add 1 to both sides so that y would equal 2. And so there's my full answer for question number 9. So on the second part, it says using subtraction. What we're going to do is we're going to multiply everybody by a negative 1 in one of the two equations. It doesn't matter which. Both of them will work, and that should cancel our one of our two variables. All right, I hope this video is not too long, but it shows you the steps you're going to have to take to be successful. Please send me information with where you're stuck or things that aren't making sense. Give me a chance. Let me help you out. All right, good luck, and have a good Thanksgiving.